Hi, and welcome to Lecture 9. Note that we're doing Lecture 9 before Lecture 8. And this time I'm actually going to try posting the annotated lectures along with the video, and in the other folder I'm also going to post the blank PowerPoint notes as before. Today we're talking about balking and reneging. So what are these things? Balking occurs when an arriving entity chooses not to enter a queue. So for example, a midshipman arrives to the Nimitz coffee bar and decides not to get coffee because of the length of the line. So we've all seen balking. Balking is the idea that you get there, you see the line, you're like, nope, not gonna do that. Reneging occurs when an entity in a queue chooses to leave before receiving service. So a midshipman is waiting in line, but has to exit the line because it's just taking too long and they have to go to get to class. So we've all experienced, I think, both of these things, or I imagine we have. I suppose there's some of you out there who you get in that line and you just do it, but I think that's quite rare actually. Anyway, that's what we're gonna learn how to model today in Simio. So in the Nimitz coffee bar, and again, I definitely recommend that you pause video, follow along with your Nimitz coffee bar open. You'll get the most maximum value out of learning how to do this stuff in Simio if you do that. Okay, so what we're going to need to do is we're going to need to create different objects, again, different sinks. So these are going to remember how we've now talked about having different sinks. We're going to have a sink for the balks and a sink for the reneges. And this is going to allow us to keep track of who balks and who reneges. You actually don't need them, but it's going to be handy to have them so we can understand who is balking and who is reneging. Okay, so where do we figure that out? So for this particular model, we're going to actually think about the cash register server. Now remember, the cash register server requires a barista person to check out the person. We're going from we really are starting from, their starting point here is the conditional NCB with resources. Okay, so that's the model that I'm changes. But you could start from any of the models that just put in balking. It is independent of the resources. Anyway, so what happens? The person, we wanted first model the balking, and so we look at this buffer logic field, and if you look at the buffer logic field, you'll see down here there's a balking and reneging options, and you can check that open to open up the balking decisions. Okay, so when you look at that, this is the expanded properties menu. You can see there's different types of balking. There's input buffer capacities. And I'll note that customers do not balk if you have none. And then there's 3 other possibilities. So there's 4 total. There's blocked, and that's customers balk whenever the queue reaches a certain capacity. Conditional, there's some condition, some if-then logic there. Or probabilistic, it's based purely on a probability. So blocked balking, the idea here would be if there's a certain number of people in line, the midshipman balks and they don't join the line. So if we assume, for this, just the sake of this example, we'll assume that if more than 5 people are in line, then the midshipman balks and does not join. Okay, so what we do is we put in the buffer logic, we put in a capacity of 5, and the decision is blocked. And then we send them, when you click on here, you'll see all these different, it'll say input at, and that's basically this little node here. And so we send them to this input at balks. Okay, so if more than 5 people are in line, the midshipman balks and they don't join. And that's how the buffer logic works. Okay. So if there's instead a midshipman decides to join the line, if no more than 10 people are in the system, this would be an example of blocked bulking. So again, we're going to change this, and we could, we could just change this number to 10, and that would do that same thing. Okay, so that's how you would do block bulking, and so that's a fairly easy one to implement. Now, if we're going to do assume a conditional bulking, a midshipman decides to join the line if no more than 10 people are in the system, we can just do a conditional, add a condition here, and we're going to say if the number in system. Now note, this isn't the number in line, this is the total number in system. So this is like the midshipman comes in, looks what's going on, and says, boy, it's really quite busy overall here. There's a lot of people here, and I'm going to leave if I see more than 10. So this is the logic that we put in there. We put the condition, and then in the condition we can use our selection. Remember, you just start you click on that this down arrow, and it'll give you all the different properties you can select from. You would select midshipman. Remember, that is driven by, because that's the entity name. You type dot, and then you're going to want to select population, and then dot. So when I say dot, I mean period. You click on number in system, and you want that if that's greater than 10, then there is a bulk. So remember how this logic works. It's if this condition is satisfied. So if condition, then bulk. Okay, so this is the condition, right? Midshipman.population.number in system greater than 10. Okay, so now let's assume that if this condition, or let's just assume there's a 5% chance that each midshipman bulks. They come in and they're like, well, am I going to bulk? We don't know. We're not going to, in some sense, this is slightly less modeling than the condition. The condition one, you might over model if you think about it. Does everybody just really calculate 10, or do they just say, well, it's busy? And so one way to sort of get at that a little more roughly, which might be a more accurate way of doing it, we always have to be careful of overfitting a model, is you just say, well, no, about 1 out of every 20 does this. We can observe that 1 out of 20 midshipmen bulks. And a priori, maybe that's a more accurate way to model it. So we switch this to probabilistic. Remember the drop-down choices, that was a choice. And then instead of condition, we're going to put a probability, and we put 0.05. And then there's this 5% chance that each midshipman bulks. Okay. Now, we might have a slightly more, sort of a more interesting condition. Maybe they're only willing to wait in line for 5 minutes. Now, when we get to this, of course, what are we talking about? We're no longer talking about bulking, we're talking about reneging. Okay, and so here, we're going to have to look at the renege triggers. And when you click on this, you're going to see that the 3 over here, there'll be the 3 ... dots, similar to when we were doing resource seizes and resource releases. And when you click on those ... dots, you get this. And again, it's this idea where you're going to add a line there because you can add multiple triggers for reneges. And we see up here again, there's trigger types. We're going to be looking for time-based. With the time, we're just going to put 5, and we have to be sure to change the units to minutes. Okay. Now, maybe not all the midshipmen have the same weight tolerance. So we might assume that as few as some wait as few as 3 minutes, while others wait as long as 10, but most wait 5. So you should think of this as the mode of that distribution. And of course, what we're looking at here is a triangular. Anytime we see a lower bound, an upper bound, and a mode, in other words, most midshipmen wait 5 minutes, that's the mode, we think of the triangular distribution. Okay, so here, and instead of a constant number, again, we can pull that drop-down menu and either select random or just type capital random dot capital triangular, then 3, 5, 10. Okay, so we put in our min, our mode, and our max. Okay. Now we might we might say, well, maybe when they hit their wait duration, it's just a chance they're going to leave, right? So we might say, well, instead of always here, we might change that. So maybe they decide to remain in the system 10% of the time. Okay, so you select this, you check, instead of always, you're going to select probabilistic, and then the reg condition or probability setting you change to 0.1. Note also that you had to also select what happens to them. And when you select what happens in any of these renegings, we want to send them to the right node, which is the right sync node, which is input at renegs. Okay. So maybe we model it more closely. Maybe so we say, well, if once they reach their duration, they're going to choose to stay in line if they are the next person to receive service. Okay. So we're going to change this stuff around so that instead we have conditional, and then it's this kind of interesting logic. It's cashier.allocationQ.index of item, and then we have to put parentheses entity. This bit here refers to the allocation queue, and then we're going to look for the index of the item, which means where they are, what position they are in the queue. And so we want, if it's greater than 1, which means that their index, their position is not first, then they renege. If it is first, then they're going to stay. So, and that would model that logic.